This is a geometry lesson on symmetry. First, let's look at lines of symmetry. Here's some hexagons. How many lines of symmetry does this first one have? It's not regular. Here's one. Just recall, a line of symmetry is such that if it's right in the mirror, it looks exactly in the mirror as it looks. Here would be one. The vertical would be a line of symmetry. You can tell easily the left side is the same as the right side. Just a mirror image, conveniently. We also have one here for the top and the bottom. So the top and the bottom looks like a reflection. Now you might have a tendency to say, well, what about the diagonal? Notice the diagonal doesn't work. If I put it down horizontal like this, you can kind of see that the top is not the same as the bottom. It doesn't look like it's a reflection in a pond or something like that. So for this particular hexagon, which is not regular, there are two lines of symmetry only, the vertical and the horizontal. And what about the regular? Now the regular has more. It's got the two that this other one had, the vertical and the horizontal, but notice it also has the diagonals, and those would be the same, assuming it's regular. Okay. That'd be like that. Now that figure's not exactly close, but you can imagine. So what about this hexagon down here? Yes, this is an irregular hexagon, and it only has the one reflection from top to bottom. That's it. Okay. Some items in nature. Okay. Butterfly has one line of symmetry, and it's already noted right there. A buttercup has two lines. Look, there's that one. When you're evaluating these, do it by categories, okay? So the categories then would be for this buttercup would be right in the middle of the petal. So that's in the middle of the petal, and that's in the middle of the petal. So there are two that way. I'm saying think about a category to do it with, because if you just start counting, you say, oh, well, in the petal, in the petal, in the petal, in the petal. So, well, there's 4 lines of symmetry that I've just counted. No! It had to start at this petal and end at that petal. So make sure that you're not counting it twice as you do that. So you'd have the two that are in the middle of the petal, and then you have the two additional ones that are between the petals. So this buttercup has 4 lines of symmetry. Okay, that takes us through the lower level type of symmetry. Now for a little bit more about the geometry symmetry. The first thing we're going to talk about is rotational symmetry. Okay, rotational symmetry, write this in your cipher, means that the shape appears oriented the same after the rotation is completed. So what we have here is here's our original position with 0 rotation. Notice that 0 looks exactly the same as 90. Now, I know it's not the same little blade of this whirligig thing that's here. The top one moves to the left with the rotation, but the appearance is still the same, even though it has rotated and it's actually a different blade of the little twirly thing. It also occurs again at 180. Notice that 45 is not the same. It doesn't look the same. I can tell that it moved. It is crooked. When we describe the rotation, we'll talk about the period of rotation. That's ever so many, however many, it's going to look the same. This one looks the same every 90 degrees. So it'll look the same at 90, 180, 270, and 360. It will appear the same. It'll appear oriented the same. Because the ones that are bigger than 180 are just add 180 added to it, we only talk about the ones that are 180 or less. And again, this is rotation about the center of the figure. So in this particular figure, the ones that there is rotational symmetry at 90 degrees and 180 degrees, not at 45. There is rotational symmetry at 90 and 180. There's also rotational symmetry at 270, but we don't talk about it because it's kind of like a duplication. So let's put some examples here of these. Okay, there's my little fan, and here we can see it. Say if I want to start with it like this, it doesn't matter which way I start with it. If I start like that and I rotate it 90, it looks the same. I rotated another 90, it looks the same. I rotated another 90, it looks the same. And then back to the original. Again, we didn't care that this was a different one that was in the place. What we care about is that it appears to be the same orientation. This is not the same orientation, so this is not one of the degrees at which there's rotational symmetry. Let's play with a few of these and see what we can do with it. Okay. Looking at this figure, can you tell by looking at this figure if it has rotational symmetry? In other words, if I attempt to rotate it, will it still look the same? And if so, when? Okay, well, I think you can probably tell that this one is also 90 degrees. Again, rotation is counterclockwise by default, unless we say otherwise. So I just rotated it 90 degrees counterclockwise. It appears the same. Another 90 to 180, it appears the same. So it has rotational symmetry at 90 degrees and 180 degrees. It also has it at 270. I can do it again, but we just don't talk about that one because once we've done the first half, the second half is the same. Okay. Does this item, lightning bolt, have rotational symmetry? Okay, well, let me try it. I'm going to rotate it. It looks different. Yeah. There's only one time it's going to look the same, and that's at the original. So we say it does not have rotational symmetry because the only time is at 360. See, there's 180, there's 360. So we say there's no rotational symmetry. How about a regular pentagon? When will that have rotational symmetry? It does. Notice that it will look the same when a particular point, any point, is pointed in the same direction. So if we're starting with a point pointed up, then every time some point is pointed up, it will look the same. It will have rotational symmetry, since it's regular. Well, how many times does that happen? 1, 2, 3, 4, 5. It happens 5 times that some point is pointed up, and that's going a whole 360 around. So 360 divided by 5 is 72, and that's the period of rotation. So it will appear oriented the same at 72 degrees rotation about the center, and then at 144 degrees rotation about the center. Notice that the next one is too far. It won't be, it's past 180, so we don't talk about that one. Okay, how about this part of a smiley face or a moon or something? Okay, I'll start with it like this. Is it ever going to look the same as I rotate it? Here, I'll rotate it. Not looking the same. There's a smiley face. Still, no, doesn't look the same. Never looks the same. We say it does not have rotational symmetry because the only time it looks the same is when it comes back to the original. How about this square frame? Okay, well, when I rotate it 90 degrees, it looks the same. 90 more degrees to 180, it looks the same. 90 more degrees, 90 more degrees. So, it is rotationally symmetrical at every 90 degrees, a period of 90 degrees, and it has rotational symmetry at 90 degrees and 180, recalling that it also has it at 270, but we don't count that one. We just count the ones that are 180 or less. Okay, how about a raindrop? Raindrops keep falling on my head. Okay, well, do they look like raindrops anytime? Any other orientation? Oh, no, they do not. No rotational symmetry for Mr. Raindrop. How about this big plus? Yeah, I think you're probably catching on. You can see that it's going to be every 90 degrees at 90 and 180. All right, what about the right triangle? How will it be? Oh my, if I start rotating it, I still have a right triangle, but it doesn't look the same. It's not oriented the same unless it's in its original position, so we say there is no rotational symmetry. How about this parallelogram? Is it going to look like that again? It doesn't, it doesn't, it doesn't, it doesn't. It does at 180 degrees. And I think you can see that that's the only point of rotational symmetry. What about this little sun? When's it going to look like that? It's pretty symmetrical, so I think you can see that if we start with one ray of sun pointing vertically, that whenever any ray of sun is pointed vertically, it will look the same. Okay, well, how many of them are there? 1, 2, 3, 4, 5, 6, 7, 8. There's 8 of them over 360 degrees, so that would be every 45 degrees it will have rotational symmetry. So that'll be at 45, 90, 135, 180, and on past that, but we don't count them. Just for fun, here's a nice little puzzle. Does it have rotational symmetry? You tell me. And if it does, when does it? Okay. And here ended the lesson.